Okay, a perfect square is the result of squaring a quantity, squaring anything. So 1 squared is equal to 1, therefore this 1, it's the result of squaring something, is a perfect square. 2 squared equals 4, so 4 is a perfect square. 9 is a perfect square. 16 is a perfect square. Basically anything that you can get after you take something, so you take something, you square, and the result, like in this last example was 16, that is a perfect square. But here's something perhaps surprising. If you take c to the first and square it, well, you get c to the second. And so c to the second, c squared is a perfect square. If you take c squared and square it, you'll get c to the fourth, so that's a perfect square. If you start with c cubed and then square that, you'll get, the result will be c to the sixth, and so c to the sixth is a perfect square. And if you take c to the fourth and square it, you'll get c to the eighth, and since c to the eighth is something squared, namely what was in parentheses, squared, since c to the eighth is something squared, c to the eighth is a perfect square. And let's be really careful about what we're saying here. I didn't say that 8 is a perfect square. You did not hear me say 8 is a perfect square. I said c to the eighth is a perfect square. And that distinction is important. Okay, so I'm saying 9 is a perfect square because it's 9 is something squared, and I'm saying c to the eighth is a perfect square because c to the eighth is something squared as well. Okay, so based on what we see here, that c squared, c to the fourth, c to the sixth, c to the eighth, c to the 10th, and c to the 12th, those are all examples of perfect squares. Do you notice a pattern? So here's the interactive question. When you have c to the k, where k represents the exponent, what must be true about k so that c to the k is a perfect square? For example, is c to the 38th a perfect square? Is c to the 39th a perfect square?